Hello world, my name is Victor Engelmann. Welcome back to the series on professional network design using Linux. Today I want to talk about Wireshark, and well, Wireshark is not really something for designing a network, but for maintaining an existing network. It's a program that lets you look into the network packets that are going around in your network, and this is really useful when anything goes wrong. Then you can really analyze things really down to the last bit if you have to. And let's jump right in. So first of all, I will install it. Wireshark-Qt is the name of the packet, at least under Manjaro, because there is a Qt front end for Wireshark included in this packet. And these Wireshark packets on most distributions are really well maintained because many people use them. So if anything goes wrong, like if some dependency is missing or something, somebody is going to notice it, and then it gets fixed. So this is really reliable. Okay, now I have installed it. Now let's run it. Okay. I'm running it with administrator rights. If you are doing this on Windows, the installer asks you if you want to limit it to administrator rights, and if you have this option, you should say yes. For security reasons, but also I found that on Windows, if you try to allow it for all users, the packet capturing driver for your network card had some problems, and it just didn't work without that. So if you're doing it on Windows and it asks you whether you want to limit to administrator mode or not, I would advise you to do it. Okay, so here this is now how Wireshark looks. Okay, and the first thing you have to do is you have to select one of your network interfaces. Here, this is my network interface, my wired network interface. And you're already seeing a lot of data going in and out here. It's kind of scary sometimes because it looks like, what on earth is going on in my network, right? Why are there so many packets? But that's really normal. Like here, for example, ARP requests, the network has to maintain itself. So the devices have to talk to each other and notice changes and stuff. So it's not unusual to see a lot of packets here. Okay, and when you are done capturing packets, you can click here on this stop button. So now my capturing session is done, and I can export all these packets, save as, and select some PCAP file. That's a packet capture file. This is something, for example, when you have classes on this topic, you might be given such a PCAP file for your homework assignment or something like that. You can register Wireshark as the handler for the MIME type for PCAP files, and then when you double click the PCAP file, Wireshark opens up, and you will get this view with these captured packets in it. So that's really handy. And here on file open, you can also load such a PCAP file again. So that just stores the captured packets and restores the captured packets, so you can just go back to a previous capture session like this here. And when you have captured packets, let's take this one here, this ARP packet, then down here you can really look into it. Here you have the raw data here on the right, where you can look really into every bit if you want to. And here you have this tree representation of the packet, where the packet is deciphered in a way where you have the frame, which is really the raw data, the Ethernet frame containing all the data, and then down here the Ethernet frame, where you can see some things like the MAC addresses of the involved devices, like this here, MAC address FFFF. That's a broadcast, as it says here. And Wireshark is really good in deciphering what all that means, right? As it, for example, says here, this is a broadcast, or down here it says this MAC address, the first 3 bytes of it are a vendor-specific prefix, and Wireshark has a list of these vendors, so it knows that this MAC address belongs to a TP-Link device, and this 89.4B43 is then the last 3 bytes here. That can also be a useful information if you're not sure which device is that, then you at least know the vendor of the device, which might help you figure out which device it is. Although network switches often let you look into their ARP table, and then you can follow you can follow a packet like that. So you would look into the ARP table of your switch and see, okay, a packet to this MAC address will go out this interface, and then you look, okay, which device is connected to that interface. So if you see, for example, that this MAC address, for example, would go out on interface 8, then you would just go to interface 8 of your switch and follow the cable. Where is it going, right? Okay, that was just an aside. So this is the Ethernet frame with the MAC addresses, and here we then have further information. This is an ARP packet, so it's using IPv4. Up here we have the type 0806. If you remember my video about the anatomy of network packets, this is an ARP packet. So this is going to the ARP handler, and it has the opcode 1, which is a request. Wireshark again readily tells us opcode 1 is a request for the MAC address of this IP address. Okay, and then we should get a request, a response here. Okay, I don't find a response, but that's already the problem. There's so much data here that it's hard to find your way through it, right? And that is why up here you can filter your packets, and this is really the absolute strong point of Wireshark. So here you can, for example, say ARP, and now you only see ARP packets. Okay. Strangely, I only have ARP requests, but I think, these are requests coming from my network switches. So 10, 1, 1, 11, 12, 13, and 14 are my network switches. So they are requesting via broadcast, and my machine doesn't have that IP address, so it doesn't send a response. So that is why I don't have responses. Makes sense. So mystery solved, right? So and this is what Wireshark does. It really helps you figuring out what's going on. And yeah, again, this filtering up here, this is really such a useful thing, because with this you can really focus on the things that you are interested in. And this is pretty well documented. You can, for example, Google for a Wireshark cheat sheet. I personally have this cheat sheet here hanging on the wall next to my screen with Wireshark display filters. There are other kinds of filters, but this here you set the display filter. Okay, so this cheat sheet with display filters tells you how you can write your display filters specifically. Okay. Yeah, here, for example, we have ARP. So here we could now filter for requests for a specific MAC, or for requests or responses, whatever. So and yeah, if you have seen my video about the anatomy of network packets, then this is really telling you everything you need. Like if you need if you're looking, for example, for a TCP IP connection between your machine and a different machine, right? Then you might want to filter for the IP address, and the IP address is something here in the IPv4 block. You could filter here for the destination host or for the source host. But of course, if you remember my video about the anatomy of network packets, you won't find a port number here in the IPv4 list, because IPv4 and IPv6 don't have port numbers, right? If you remember that video, IPv4 is just for the communication between different machines, right? I send data to your machine, and the data that I'm sending is the payload of that packet. And yeah, with IPv4 I can just transfer it to you. But yeah, the port number is a TCP attribute, right? So the IPv4 handler would take the packet, take the payload, and give it to the TCP handler, right? And the TCP handler would then look at TCP port. So this would look into the port, and based on that give the payload of the TCP packet then to the program that's listening on that port, for example. Okay, and yeah, there's really too much to talk about here. You can even filter for specific flags in the TCP flags, right? This is, you can really drill down deep into the stuff. So there's really nothing that you could wish for that it doesn't do, really. I'm really serious. This is so complete. It does everything you could possibly want. And yeah, this is quite similar to the syntax of C. Okay, so you have the logical AND with 2 ampersands, 2 pipes for a logical OR. You can have an exclamation point for not. You can use operators like equal equal, exclamation point equal, greater less, greater or equal, less or equal. And yeah, with these identifier dot another identifier, this is very much the way in C you would look into a structure, right? So so yeah, if you know C, then this is already pretty self-explanatory here. Yeah, so let's look into a TCP connection now. Okay, I've closed the capture session, and I will start another capture session now. Okay, and Okay, without a filter, it again lists everything. But yeah, now I have here these two shell windows, okay, where up here I'm logged into my LDAP server from the last video. And up here I will now run netcat listening mode, listening on, let's say, port 8000. Okay. And down here, this is locally on my laptop. So netcat LDAP server.engelmann.local port 8000. Okay, now I'm connected. Okay, if I send something here from my laptop to the LDAP server, it arrives here. Okay, and I can respond. Okay, now again, we are seeing a lot of traffic here. We are seeing a lot of packets, and it's just too much to really follow this in real time. Again, you could now, after we've had this traffic going back and forth, we could now stop the capturing and then look through the packets that we've had, possibly using the filters, but you might want to do this online while stuff is going on. So yeah, this also works while it's running. So let's see, IP dot destination equals, what's the IP address? Okay, 10.190.55. Okay. Okay, now I'm only seeing packets that are going to 10.190.55. Okay, yeah, SSH protocol is encrypted. If we are looking into that, we won't see very much. So let's say and not SSH. Okay, now we filtered all the SSH stuff out. Destination port 22. Looks like also SSH traffic, so don't know why it shows that, but yeah, let's say and TCP destination port equals 8000. Okay, now we've broken it down to really just a few packets, and that's really good. And yeah, this is really a good point here. When we break this packet down, right, you have this Ethernet frame as the outermost frame with the MAC addresses containing an IPv4 frame containing the IP addresses of sender and recipient, then the TCP frame containing the port number and some other stuff, and down here the last 6 bytes of this packet. Yeah, this is really this hello, okay, and 0A is a carriage return because I've pressed return, right? So so this is really the text that I had sent from my laptop to the server. And yeah, now let's say the server asks something like password, and then I input my password 1 2 3 4 5. Okay, now get this. Okay, here I'm now only getting the communication going to the server. Let's see. I change this to IP address. So this now also yeah, if I say IP address instead of destination address, then it filters for packets that are either coming from or going to that address. And with TCP port, I'm filtering things that are either going to port 8000 or coming from port 8000, right? So now I'm seeing also the traffic coming from the server, right? So yeah, here we have this query. What's the password? And yeah, you always see these TCP status messages in between. We could also filter them out, like I don't want to see SYN packets, I don't want to see ECK packets, right? That just might not be so interesting, but we don't have so many packets, so I think we can just look through them. So here we have the server asking for the password, and here we have the response. So here, by reading this connection, I was able to read the password that the user had sent here over this connection, right? And this is really, 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 really dangerous, okay? If you have unencrypted connections, somebody might be reading your traffic and might be reading your passwords. And this is exactly the reason why experts tell you to not use FTP anymore and to not use Telnet anymore, because these are unencrypted systems. If you're using these, somebody might capture your password. Okay, and this is just super insecure, and because of that, you really should use SSH instead for SSH-based file access and for remote access to a shell, okay? Because SSH is super encrypted, that's really secure, and Telnet and FTP aren't, okay? Now another really useful feature is, I mean, Wireshark has a lot of features, okay? I can really not go into all the features. I would advise you to go to YouTube and watch some videos of the SharkCon, I think it's called, where people discuss Wireshark. So this is a whole convention based on or for Wireshark, and you pick up a lot of useful stuff there. But yeah, what I want to show you is here you can right click on a packet and say follow TCP stream, and yeah, now this here strips away all the data and only really shows you the data that's going back and forth over the TCP connection, right? We have hello world, password 12345, and in different colors indicating which direction the data went. Yeah, so that's another really useful feature, and making it even easier to capture or to read your passwords if somebody reads your connection. Okay. Okay, now what I've shown you now is a pretty simple case. Okay, because one of the two machines involved in the connection was my laptop. Okay, and this is something that many videos about Wireshark on YouTube do wrong, because they show you yeah, how to capture or how to read a connection, but it only works locally. It only works when one of the machines of that connection is the machine you run Wireshark on. And yeah, that's not really what you do in practice, right? If you're interested in the data going back and forth on some connection, usually one of these machines is not going to be your machine, right? So what can you do to read data going back and forth between two other machines? Because remember, if two machines talk to each other, they query through ARP each other's MAC addresses, and then put the MAC address into the packet, and then the network switch will direct the packet directly to the recipient, and just because you are in the same network doesn't help you, because the packet just passes you by. Okay, and if it passes you by, then there's just nothing physically arriving on your network device which Wireshark could even capture. Okay, and that's a problem, because the way I've shown you so far, it's not going to help you reading data going back and forth between two other machines. So what can you do about that? Well, one way you can solve that problem is with ARP spoofing. So you would effectively do a man in the middle, which means that you would send a fake ARP message to both machines, telling them, hey, my MAC address is the MAC address of that IP address, and that other device you are telling, hey, my MAC address, that's the MAC address for the IP address of the other machine. Okay, so that both machines would believe that your machine is the other machine they are trying to talk to. Okay, that's how man-in-the-middle attacks work with ARP spoofing. And then you have to run something that takes the data for this IP address and then forwards it so that the machines actually can talk to each other, right? It's otherwise they wouldn't have a connection to read, right? The connection would just fail, and then there's nothing for you to read. That's a bit complicated, and that's not what you would do in reality. Just because already you cannot just do a man-in-the-middle attack in a corporate network, for example. You cannot do ARP spoofing. If the IT department finds that out, like they might be reading broadcasts with ARP responses and looking for responses where the MAC address doesn't match the IP address, right? And then they know, hey, one of our machines is doing a man-in-the-middle attack. The guy doing that is getting fired now because they are sabotaging our network, right? Okay, so the way you would do this in reality is, in reality, if you are a network administrator, you will be able to log into your network switches, and here you can typically go to a setting for port mirroring. Okay, and the switch that I have here allows me to enable port mirroring, let's say on port 8. Okay. And then down here you can select which ports you want to mirror to port 8, which then means every packet that's going through port 3 will be copied to port 8. Okay, everything that's going in and out of that port will be copied to port 8, where then it's going to my laptop and I can read it. And port 3 is where the LDAP server is connected. Okay, so let's open a new window. see. Okay, now I've logged in to yet another Raspberry Pi. Okay. Now let's disconnect here. Okay, now let's connect these two Raspberries and have them talk to each other. Yeah, on the LDAP server I will run netcat listening mode port 8000 again, and on my other Raspberry I will run netcat LDAP server.engelmann.local port 8000. Don't forget to allow it on your firewall if there's a firewall in between. I just had a little bit of fun with that. Okay, so this is now the connection between them. Okay. Start another capturing session. And now let's have some traffic here. Okay, and now let's filter for packets that are going to 10.1.90.55. Lots of retransmissions. Why is that? Whatever. Okay, and 10.1.22.50 is the other Raspberry. So here, this is a packet that's going from Raspberry Multimedia to the LDAP server, right? This is both not my IP address. Normally, I shouldn't see that, okay? I'm only seeing that because of the port mirroring. And yeah, now I can say follow TCP stream, password 12345. Okay, so yeah, now we have seen how we can look into data going between other machines. But of course you need administrative access here to your network switches for that. But yeah, in terms of the design of your network, I would advise you to yeah, have a typical star topology with one central core switch, and then attach to that other switches, and which then have the connections to all your machines. But yeah, I would reserve one port on each of these switches for this port mirroring, okay? And yeah, then you can read the data that's going back and forth there, and find out people's passwords if they are not using encrypted connections. Okay, so that was all I wanted to show you today. If you liked this video, like it, share it, subscribe, and see you next time.